In this screencast, we're going to look at fixed and variable costs. When we were doing financial accounting, we classified cost as either product costs or period costs. Product costs were cost of goods sold, period costs were operating expenditures. This was helpful for facilitating the matching principle, which is very important for measuring income. However, if we want to forecast future costs, most people find it easier if they think about costs in terms of being either a fixed cost or a variable cost. We sometimes call that cost behavior. Here's an example of a fixed cost. The basic idea behind a fixed cost is that if you go from one quantity, the cost is here. If you then increase the quantity over some range, the cost stays the same. In other words, the total amount of the cost doesn't change. And we normally assume that this assumption only holds over a given range of activity. So we're not sure what would happen over here, and we're not sure what would happen over there. For variable costs, it's a little bit different. We assume that variable costs, if we're over here, then the total variable cost is this, and if we're over here, the total variable cost is that. In other words, the total variable cost increased as the unit of activity increased. Now, the cost per unit for a variable cost doesn't change, and that's because the cost per unit is actually given by the slope of that line that I've drawn. So that's the slope equals variable cost per unit. And we simplify the problem by assuming that that's constant. I'm not claiming that it is always constant, but for the types of calculations we're going to do, we assume that it is. Now, the total cost is what happens when you just take the fixed cost and add the variable cost. So what that means, for example, is that if the level of activity is over here, then the fixed cost is here, the variable cost goes from here to there, and then we end up over there as the total cost. If we're at a different level of activity, then the total cost once again increases, but it increases because the variable cost has increased. The fixed cost has stayed the same, but the total cost, because it's the sum of fixed and variable costs, increases. So the cost equation is used to forecast total cost. And as you saw, it has a fixed component, which is the fixed costs, and a variable component, right, which is the variable cost per unit times the number of units. If we had a cost equation that was equal to, say, total cost is equal to $100, the fixed cost, plus $10 times the quantity, then we would expect that if we knew what the quantity is, we could reflect that off the total cost curve and figure out what the total cost is. Is just substitute in different levels of Q. So we could think of Q equals 10, Q equals 20, etc., and we would end up with different total costs. Now, if we had, for example, Q equals 15, then the total cost would be equal to 100 plus $10 per unit times 15. And if I did the math right, we would end up over here on the picture, and that would imply a total cost of $250. Notice that the fixed cost component is 100, and the variable cost component is the 10 times 15, or $150. To finish up, here's a table. So I'm going to vary the quantities 10, 15, 20, 25, 30, 35, etc. The fixed cost stays constant. Now the total variable cost, right, is the quantity times $10. So for quantity of 10, we see the total variable cost is 100. And when you add these two up, you get $200. If we were to come down to, say, quantity equals 25, we would see fixed cost of 100 plus 25 times 10, or $250 would be the variable cost component, and the total cost component therefore would be $350.